data visualization, data science, Python, matplotlib, seaborn, plotly, Part1. Data visualization is very important in the field of data science, and Python is the most common language, programming language that is being used to perform data visualization, data analysis, analytics, machine learning, deep learning, and other. Matplotlib is the most famous library for static data visualization. Creates any chart with a great customization level. Offers a range of two-dimensional plots and tools for figures and charts. 2. Seaborn. It's built on top of matplotlib. Matplotlib is the foundational one. Now these other graphics in Python, they are built on top of matplotlib. The seaborn makes charts prettier with less code seamlessly. Seaborn elevates data visualization by providing a higher level interface and stunning default themes, ideal for attractive and informative statistical graphics. 3. We have plotly. It delivers interactive visualizations, ideal for dashboards and web applications. Part1. Number 4. Creates statistical visualizations with graphics glamour inspired by ggplot2 in R. So those who are well familiar with tidyverse and ggplot2 mapping in R have got an advantage, because the Part1 is just adopting the concept of ggplot2. Alright, there are several collections of Python graphics. Of course, these are not only in Python, they are common in all programming languages like R, Python, Stata, and other software packages, statistical software or programming languages. You will see most of these. We have grouped them into 8. 1. Distribution. So those which are related to distribution, there are many, but I'll just cover the most common ones. So under distribution, we're saying we've got distribution, and then we've got the other 7. There are 8 collections, and in each collection you've got, it's like a class or a group of Python graphics or Gare, and then like the distribution is one of the Gare, it's one of the collection or one of the group of graphics in Python, and then it has got these specific ones, the violin, which can be used as a violin statistical or violin musical. We have got the density, which will also have the cumulative density, and then we have the histogram, the box plot, the ridge line, and we have the B swarm. Some other people call it swarm plot. So 1, 2, 3, 4, 5, 6, 6, but there are also other distribution collections or visuals or graphics. Okay? But these are the most common ones when it comes to visualizing the distribution of the data set. Okay. Correlation, that's number 2. In correlation, we deal with scatter plots, heat maps, correlograms, bubbles, connected scatters, and then the contours, the 2 density. Okay? So that's like 2-dimensional density functions, whereby this one is 1-dimensional, 1D density. This one is 2 density, and you can as well have 3D. So we'll see in another place. Then we have number 3, ranking. So when it comes to ranking, we use the bar plot, or some people call it the bar chart, the spider plot, or the ladder plot, bar chart, spider chart, the word cloud, the parallel, the lollipop, the secular bar plot, and then we have the tables. These ones are used for visualizing ranking. And then we have those which are used for visualizing part of the whole. So it's like filtered. So these ones are the or conditional. We can call them filtered in a filtration manner or conditional manner. So these are also can say subsetting or subpopulations. So these are tree maps, the Venn diagram, the donut. So in other words, it's like we were looking at part of the whole tree map, part of the Venn diagram, part of the donut. So we see which one takes greater part of the space of the tree map, or of the Venn diagram, or the donut, or the pie chart. So it's like over the continuum space, and then we're seeing how the data set maybe across categories or subgroups or categorical variables are distributed or are divided to sum up, to exhaust the whole population or sample. The dendrogram, the pie chart, the secular packing, the workforce. Evolution. When we are looking at evolution now, we look at now as time goes, you see this progression. So some people they say evolution, or they say progressions. We call it progression as well. So line chart, the area charts, stacked areas, string graphs, characteristics, and time series. We look at the evolution. This is number 5. We've got 3 more. Stay tuned. 6 and then 7, 8. Map. We have map, colopleth, hexpin, cartogram, connections, and bubble maps. 7. We have got the floors. So with the chord diagrams, that's the flow now. We are looking at now the flow like in queuing theory or graph theory. So we look at the chord diagram, the network diagrams, the Sankey diagrams, the arc or flows, we call it diagrams or flows, the arc diagrams, and the edge bundling. So these are they're very interesting when it comes to flow, whereby maybe we're looking at a queuing theory, or looking at like how the flow, the trafficking, yeah, so we can use the word trafficking, something like this. So we're talking about network and the trafficking, all this. And then we would 8, the last one, which is general knowledge. So these ones, we can use the colors to visualize our data, we can use interactivity, animations, cheat sheets, we can use caveats, we can use 3D, and we can use also the statistics. So we can have the graphics with embedded with statistics, or with colors, or with animations. So these are just the general. Okay, so if I just take you back, you see that we have got distribution, correlation, ranking, part of the whole, evolution, and then we have map, flows, which are trafficking, and then we have map is like mapping. Of course, we deal with mapping. Then we have the maps, like the ArcGIS and like. Okay, we have the QGIS, and you can also use R, can also use Python. Okay, we have the like ggplot2, and like we have also the INRA, RINRA, and like the general knowledge I've already explained, and then end of PowerPoint presentation. But this is not the end of today's tutorial or lesson. This is just an introduction. Now let us go to what we're covering today. So if we go on the let me go to the direct to the Python. So we're looking at main Python graphics collections, and today we'll cover the first one, the distribution, the voting, densities, histograms, box plots, ridge lines, and swamp plots, or B swamps. Okay, so these ones we'll cover today, and then in the other video we'll go in that order, which means the other video we'll have to go to let's check where did I open. Okay, it was here. Okay, so the other video we'll have to go in this order to correlations, maybe the distribution where many always see the starting part. So when we go to these others, we'll be combining maybe 2 of them. Maybe we'll do now in one video 2 and 3, correlation and ranking, and another video part of all and evolution, and then another video maps, and then lastly the other video the flows and the general knowledge. Okay, so maybe there will be about 4 or 5 videos. Okay, so remember to subscribe so that you don't miss these videos. Alright, let's proceed with number 1, which is the distribution. Okay, so if you can see, I've started by, okay, I'm running in my Python in Google Colab, okay, just on the browser. So You can, if you, some of you guys maybe use the Jupyter notebooks, others they use maybe the Visual Studio. There are so many techniques you can use, the spider. So whichever you are using, by the end of the day, you will be doing the same things. Okay, so I prefer using the Google app. Why? Because it's like I don't I'm running away from now and again installing libraries, packages and the like, because on this forum they're already installed, so you don't bother with to install anything else unless if it's very special, maybe a third party or open source, something like that, Python library. But if there are those which are supposed to be embedded in the environment of Python, they are already updated on this platform. So just what we need is just to import them and use them. That's why I like. And again, you can see your work is saved, organized in the Google Drive, your drive. So, and you can share, you can collaborate. That's why this is a collaboration research, okay, Google platform. So this is a scientific way of doing things. Okay, so that's why I like it instead of using those other ways. Okay, now we have this one. I'll just run. What I'm doing here is I'm importing the operating system, and then this operating system I get working directory just to see what is my working directory, and then okay, I've imported again, so I needed just to import once. I can just remove one. Okay, and then I create the folder, a new folder, graphics. Okay, so if you can see this one, I've opened a new one, which means we just have sample data here. When you just open a new Google platform, this one, it will have just this sample data there. The README, the California housing test, the train, the California housing train, and then the mean test, and also this one, the train small, like that. Okay, so those are the ones which are the data sets that are available here in the sample data, and by default you are working in the content here. So that's why I work with the sample data, which is in the content here. Alright, so when I'm creating a folder named graphics, it will come under it means this one will come under content. Okay, alright, that's what will happen. So let me create. So if I run this one, then yeah, let me just run it. So it means it is there. Now if I can see here, it was there, but you'll see it now. Graphics just come here. Last time there was no graphics, but this graphics so far is empty. There is nothing. Okay, so now in this graphics, now I've changed the directory, so that this is changed directory into this one, so that now I'm no more working in the content, but I'm working inside the graphics. And then here it's what is waiting here. It's waiting for me to line 16 files upload. So we'll be working with these files. There are 3 files. The data, the Python data 1, I simulated these data sets. So these are just data sets which I've just simulated for the sake of this video. They are not real actual data sets. Okay, so I've simulated 3 data sets that we're going to use, and then the others will be simulating inside the video. But these ones are already simulated, so we just use them. So there will be the graph 1, graph 2, and the graph 3. Okay, now for the first one, which we want here is the graph 1. So I have the graph 1 here. Where is it? This one. So I have this one I can close. Okay, so okay, I can close this one. I will open again. Okay, so you see this one I've loaded the the Python graphics data 1. Okay, I've got 3 of them. So you can see it has got this is the size, and it has saved it. By default it will save in the working directory. So that's why I wanted, if I could go here again on this data set, if I go in graphics now, you see that now I put Python graphics 1. Okay, so now it is now in here in my working environment, in my working folder. So now I can start calling it. So the first one we're looking at volume, then we have density, histogram, box plot, ridgeline, and piece1. This is what we're covering today. Okay, so stay tuned. We're going to do very interesting things today. So the volume, this plot is for distribution of numeric variable. Can be one variable, or can be saved many 2 or many variables, and it can be one numeric and then one group variable, or one numeric and 2 or more group variables, or can be several numeric variables like that, which we call multiple variant plot. Okay, variant plot. Okay, so now we have usually we do this one in seaborn, but as well you can do it. So just be combining. We can do it in seaborn, matplotlib, plotlib, and in the other one, port 9. Okay, now let's go for one numerical variable. So if we got one numerical variable only, okay, so for example, so we load our dataset, this one, because I have it now here in my environment, so I will load the libraries and datasets. So the seaborn, the matplotlib, the pandas, and then I will read the data using the pandas. All these three are CSVs. So this is the first one, the one I just uploaded, and then we can see. Let me run just this part so that we see. Yeah, so if I just run this part, we'll see this is the data set. Okay, so I can put it in interactive manner. So we have got the index there. Okay, because the head, it will do 1 up to 4, which is 5 entries, and then we have sepal length, sepal width, petal length, petal width, and species. Okay, they're like flowers. So this is the about flowers, and we want now to plot. And all these are numeric because they are the length or width. Okay, except the species is like a group. Okay, because we have species of certain flower. So now, if we run this one up to here, what we are doing here is we were just setting the theme and the grid, the coloring of the report size, where we will figure size. So when we do like this, set everything figure size 10. This one, it means all the next plots that will be plotting here, they'll be using this setting. Theme setting, unless if you want to change it, then you have to repeat this line and make changes inside here. Okay, so these are not the only ones. This is the figure size, but also the DPI, but you can have so many other inside here as well. You can have other options. Okay, because when you just go here, when we just go over here, it will tell you a definition how it's defined. These are functions. So it is set theme, which means I go to what context. So it's a notebook style tag grid. Okay, so it means these are the default. So it means the thing which I put tag grid here. If I did not do it, would have done the default one. Parrot, deep, the default one, and then the font is using sans serif, and then the Elio, and then the font scale is using size 1. And scale 1, I mean, and then the color codes is true, set to true, and then none. So you can change some of them if you wanted. Okay, so like here we have just put the figure ones. Okay, now I'll put them in the RC. So the RC, that's the one which again when we go into RC inside, we'll have again also the list, the dictionary, like say figure size. This one, we got the IP is this one. Okay, for the resolutions and the aspect ratios. Okay, now let me run. So if I run here, it means I'm running the whole cell, but I'll just use run selection. Okay, then now here, if I run these ones, okay, here I have deliberately commented here so that, okay, let me run the whole of this one. So if I run, then it means this is a simple one, which is the sepal length, width 0.3. Okay, these ones I've commented, so it's skipping. So plot show, so it's showing. So this is the plot. Okay, so you see, it's a simple one. You've got the sepal length, and these were the lengths from the data, and then you have the variant plot here. And inside here you've got a box plot. If you wanted the box plot to look bigger, because this one will be it has got 5-point summary, the minimum here, the maximum there, and you've got the first quartile, which is 25 percentile, and then or quartile, and then you have got the 75 here, the upper or third quartile, and then the 50%, the second median here on the white here. So you can see, then you can see how it's distributed. Okay, sometimes we would allow also whiskers inside. Okay, but here we have not put the whiskers. If you wanted, you could add the whiskers, and then we have outside now the variant plot. This one, which is trying to show as you move 4, 5, 6, 7, 8, as you go up. You do like this, read it like this, it's telling you the probability. So like here it means on 6, it's like it means that's where you're going to get this probability, which means majority, the probability that you get a 6 reading of 6 length of a sepal is here, on 6 here. Of course, it's you can see it's between 5 and maybe we can say 5 and 7, not 7, 5 and 6.5 here. So from 5 and 6.5, but below 5 you can see that the probability is small. And the width is smaller, and then the width here is small again. So this makes sense. It means the very outliers, the very small lower ones, and the very high ones should be same. So we expect the data to have match in the middle here, which is making sense. So let's proceed. Okay, but before proceed, you can want to remove the box plot inside, because here it was joined by default. When you do the varying, they put also the box plot, because if you noted, we said the varying plots reveal more data features than box plot. So it means it's an alternative of box plot, but with which is giving more also information in addition to the box plot. The box plot is very powerful at 7-point summary. These ones 1 minimum, the maximum 2, and then 3, 4, 5, the 5-point summary. Okay, and that does include the mean as a point summary, but in the box plot will not be there unless you command it to put the mean. Alright, but now let me comment this one. I comment line 15, and then I decomment line 17. So what will happen if I run again? Then you see that now what will run will be line 17. This one was the one by default it adds what I chose the width 0.3. And then but by default it puts the inner the box plot. But if you put inner none inside, inner none now, then it will remove if you don't want the box plot inside, you just have the varying. Alright, and again if I can put back this one, and instead I put run number 18. So it means in this case if I say not 18 only, if I run number 18 only, it will be a box plot only. Let me, it will be a box plot only like this. See why? Because it means I've removed the varying. But now if you do the combination, this one without this one inside, and that one this one 17 and 18 without the, so you plot a varying without the box plot, and then you overlay the box plot so that you have on top of the box plot is overlaid on top. The one which starts will be at the bottom, the one which you do next will be put on top. So these are overlaying. Okay, but it's like it's inside here, but it's not inside now. While here it was inside, but now inside is none, is overlaid on top. So you can have a bigger picture. You can see about know about the probabilities of the line, the width where there are many probabilities of occurrences, and then in terms of the 5-point summary, minimum, maximum, and then these three: the first quartile, second quartile, which is median, and upper quartile, which is third quartile. Alright, I think this is enough. Then the next, what about if we go to one variable? When we talk about one variable, we're talking about the continuous, the numeric, because when you're doing this, you're dealing with numbers, so they should be numeric. But if you've got several groups, you can have one group or several groups. It means these are the subgroups, or we call them subpopulations. Okay, so stratification, stratas. So in that case, it means if we just view again this one, what we had, so that you see, and then if you just view it, let me run this one, run, you see that it's like this. So this is the data set, the one that we have. Now if we see the display, this one is to see the frequencies, run selection, so display this instead of just head, but you do the species only, because the species are the groups. We also got one group here. Okay, so one variable and several groups. Okay, in this case this is just one variable and several groups. Okay, because the groups within the species will be many, but we can have also by several groups here. We meant we have got if we do like the one we did first, this was one group. Okay, so it's one group only, but now here several groups, it's something for two or more. I should just put it. Okay, so I've just chosen several groups, meaning even two groups or more. So here we have got species which has got more groups. I think there are 4 groups or like that. Okay, but as well you can have a factor and then another factor. So okay, we'll explain that. Let's just do this one first. So now if you run this one, then you see now that you have the species. You've got the 3 of them, and they estimated equal ones, 50, estimated 50 of each group. So there are 3 species. Okay, these flowers, and then there are 50, 50, 50. So to give you like the subpopulations. Okay, sample size, sub-sample sizes. Okay, so they could be different, but in this case they are equal. Like that. So we've got the setosa, the color, and then the virginica. Okay, species. Okay, now if you set the same, okay, we have set maybe this one now to 100. Okay, Okay, but we would just use the one which we did before, but we can also just set it again. And then if we see this one, the dictionary, we create a dictionary, myPol, and then we have these three. So we've got the G, was a dictionary for a value, because this is known as a key value pair. So the key is vesicolor, and then the value is G. The key is setosa, that's the key. The value, when we see setosa, we allocate the value B. When we see the key virginica, we allocate the key M, the value, I mean M. Alright, so let me run. I'm not writing here, running here, because I don't want to run the whole of it, so I'm running just chunk by chunk. So which means you'll see that you cannot see it yet. Okay, you're not seeing anything. Okay, this one's here. Okay, maybe what I should do is, because I was running this already, so I should clear the output. Okay, and then if I just try to see what is my dictionary, just run my dictionary only. So this is the best color. This is a dictionary. Can you see? So the key and value combination, comma, key value combination. The enter is a key value. Yeah. So now, if I go to this one, the plot now itself. So I plot. I use the seaborn because we already here. If you remember up there, we already the seaborn. Matplotlib, pandas, so which means down there if we need to use seaborn or matplotlib or pandas, they have already been loaded here. That's why I'm not loading them again, because I already have seaborn, matplotlib, pandas, they're already active, already imported. Okay, so which means here we use this for the seaborn, and then we have this function from the seaborn, which now we work on a data frame, and then the data frame is the df1, because we created this one as df1, if you remember. This one, the farm here, when we are reading it, we assigned it to object df1. So with the data set we have now, which was the Python graphics data 1, instead of showing in Excel there, the one which now, after taking it from this SSV, in the Python environment is known as the df1. So that's why whenever we see df1, we're talking about that data set that we uploaded. So we say this is the data set, and then we choose, because we just put that data set, it will take all the columns. But when we put spaces inside like this square bracket, it means in this data frame, we have chosen only this column. Okay, because those other columns were sepals and like you remember. So the y value, which is the x value, will take the sepals, that will be on the x-axis, and the y-axis on the vertical here will take in the same data, but we'll take what? This one, the sepal length. See? So there are two ways how we do this one. Okay, I'll explain. This is another way. Another way is you say data df1 and then comma x spaces y sepal length. So that these are two styles. Or you just mention the x directly here and the y directly here, like this. But when I was going to mention data df1 and then you just be choosing the column names. Okay, the hue, which is the separator, the grouping variable, that's the df1 spaces. So we use the grouping value spaces to subdivide the population. And the parent, that's the use the myPol, and then that's the color. Which means myPol is this one. That's why I did this. So which means it what we mean here. When we said for this color, it will be green. That's why it was a value. So here, this one which will say myPol, we are trying to create the colors. Okay? When we are putting this plot. So this will take green. This will take. So we are making a palette. In other words, this is creating a dictionary with one special color for the group. We call it a palette. A palette. So we have got already, we'll see as we go, we've got already inbuilt palettes, but this one is a user-defined palette. So the second one will be blue, and then the third one will be, M should be maroon, I think. Yeah. So if we can run, yeah, so we have like that. So we've got blue, green, I think this one, and then blue, and then that one. Okay. So if you wanted, another one is to put color coding like that, like a palette, or inside here in the plot here, you could put the colors. Okay, I'll explain that if later on as we go. So this one is separate, but now this one when it was 1, there was no need to label it. Okay, no need. But this one, because there are 3 now, then you need to label them. So that's why they're labeled. This with spaces here, and with the separate here, and then this spaces we've got the setosa, this color, and the virginica. Okay, and with the colors like with the box plots inside. Okay, so you can see the distribution at the center. See, you can see already that this one has got the higher sepal length than this one. Okay, and you can see exactly, yeah. Okay, so the horizontal volume plot, You see, sometimes we call it flipped variant plot. You see the same one we had in here, the same this one, because we not have to run all these above because they're already in the memory. So just change here x and y, we just swap, so that the species goes into y axis and the sepal length goes into x axis. That's all. So just swap here, the sepal length goes into x axis and this species goes into y axis. If you just run this one at plot show, then it will be the same this one which we had, but turned on its size, flipped, or it flipped like this. So that now species was here, now it will be here. So there will be these three species there. And then here, when we had the sepal length, it will be indicated at the bottom here. Last time it was here. So they just swap like this. Alright, guys. Okay. If you've got questions, you can be asking questions. Okay, so several variables now. By several variables, we mean now this we had one variable only, which was only sepal length, and then it was only many groups of these categories. One category with many. This is one category, but with many free factors. That's why here we're making a palette of free factors. Okay, what about if we had several variables, like multiple variable plot? So several of them that are what? There are all the like sepal length, and then we would have been sepal width, like that. Petal length, petal width. 4 of them, for example. So we can plot here. For example, here, if I can just see again, so that you see, I plot again this one. So that you see again, so it's what this is indexing, this is the head, so what the sepal length, sepal width, petal length, petal width, and the species. So there are what numerical, what 1, 2, 3, 4. So you can put all of these ones. You can just put these ones, and then if you want, you can put these ones and group them, so that all these ones you do for each species. Then there'll be 1, 2, 3, 4. There'll be 12 graphs. You can do just one, which will have 4 box plots and then variant plots for each. Okay, numerical variable. And then if you use this now, because this has got 3 groups, 3 species, then there will be 12. See? Okay, let me run this one. So okay, so before I run it, what you do is use the same one we did. Okay, the same. By default it is the dark grid, but now we can change. See, you can use maybe the white grid. You see, you can use the white. You can use, there will be so many. Okay, now if I use the white grid, you see how it looks like. These are things which are predefined, but you can also make your own styles. Okay, user-defined grids. Okay, so data. That's exactly what I was saying. So you just mention the data, and then when you say the data frame, then it will know. So if you say def1, and then you use this one for the location, the indexed location locators, then you here it means you take all the rows, but you take 4 columns. So when you do like that, it means it will know that you take all the columns. That's how it was defined, because it is doing for all the columns. All the rows here, the first ones, doing for all the rows. So which means the graph will be for each what? For each. But if you interchange it here, then it will be doing for the rows. Okay? If you were interested in that, but this would have no much meaning. But it would do the what? The rows. Okay. If you swapped here. Okay. So let me run this one. Okay. What it means here by saying 0 4, it means index 0 is the first one. 1, 2, 3. In this case, we don't include 4. So species is not part of this indexed location. Alright. So to just do this for up to width, petal. Okay. Now if I run, okay, in this case because I'm running the whole of it, I can just use this one. So I run without selection. Okay. So you see that. Okay. You see. So you see this is exactly what you get. So you have got 1, 2, 3, 4. See, like that. Alright. Okay, so you can see that you have like that. This one is the one which we plotted at first, okay, which was only for sepal length. So now we plotted for what? Sepal width and the petal length at petal width as well. Okay, so you can there's a story here. Okay, now we have also grouped variable plot. By grouped, it means now these ones were not grouped, but now when we grouped, it means they will be 12 now. Okay, because the same one we had. Okay, we would do the same one, but here I did another one. But if we would do the same one, then we would group by species. Okay, then there would be 12. But let us just do another one. So we upload again. This one is upload, and then we upload another file, which is the Python graphics data 2, and then that one was the one was what data frame 1. Now this one is data frame 2, and then we're going to put it head to see also what is it. And then after that, we can put the graph. You see exactly what I was saying. When you use the seaborn variant plot method or function for seaborn, you can indicate the data source here. Let me do like that. like that. Okay, so this is parameter. The variable plot. So okay, I wanted this one. Okay, so I've got the data source, you see, and then you're gonna have the x column name and y column name. Okay, then the hue is for separation. That's the one which you use for categorizing the groups. So the one with the vector or the column name or the vector, which will be hue, will be used for to do that. And the order for iterations, for ordering you use what, an iterable. And then for ordering the hue, you can use also an iterable for there. Okay, and the orientations, you can have orientations there as well, whether it's the vertical, horizontal, all those ones, x, y, and like that. Okay, now I will just okay. So here, what we say, we are saying data is the data 2, and then the x is the days, and then the y is the total bill, and then we are grouping by what, smoker. So here is the grouping variable, which is smoker, and then the palette, which was in the pastel 1. We would also pastel 2, we would also markup, we would so many, crest, there are so many. Okay, then now let me run, but when I run, it will not go to the end, it will wait here to upload first. If I after uploading, then it will proceed. So I'll run, so it will wait, it is already waiting here for to say cancel upload. If I cancel, it will just give an error that I will not give any that one. Now let me run again. So you need to choose a file. If you choose a file, now you see 2. So this is data Python graphics 2. Okay, so this Python graphics 2, you see automatically it gives you how it looks like. Okay, so but we have run everything else, it has run up to this graph. Okay, but that data set, I wanted to show you first the data set. If I go here, now I'm working in the graphics. If I go in the graphics here, I've got now the Python graphics 1 and the Python graphics 2. You see, I'm no longer working in the sample, but I'm working in the graphics here because I changed the directory to graphics. I created the new folder graphics in the content graphics, and then in this graphics, now I'm putting all my working stuff here inside. So far I've got 2. I will upload another one here, and it gives the type here. This is comma separated, and I will upload, if it's Excel, it will show you. If it is Word or like that, PDF, to show. So if it's just a folder, it will just show like this. Okay, so now this one, these are files. I will upload also the Python graphics 3 because I simulated 3 graphs. Okay, as we go, 3 data. Okay, data sets. Okay, now it's this one. Okay, now I just I code it as df2. I read it from here now, from my environment in the color play form. I read it into a variable, which is the 2, so that this variable 2 is an object that is keeping the location of what is the data. So that now def2, whenever I just say data is def2, to already pick this one, because we will already assigned to this data set. Okay, yeah. So the head here is already, it was this one. It was the head. Because when you go to run there, then it puts the head, and then after plotting this one, now you see this one now. You see this is grouped because we've grouped by this HUE. This is the variable for grouping by. So like instead of say group by, okay, or in R, okay, or even in Python. So but here in the language of seaborn, it is HUE. That's the group by variable. So what it means is now we're putting we have the total bill, because if you see here, we have the total bill, tip, sex, smoker, day, and time and size. Now we are putting the total bill as the y here, and the x we are putting the day. So it will have the days here, to put days, Sunday, Monday, Sunday, Thursday, and Friday, which means maybe the week only on these ones are observed only on these days. And then we have the smoking this side. I mean this color. The first one is a no. The second one is a yes. No, yes, no, yes. So you can choose the colors, you can change them, or the palette as well. Okay, so here you see. Alright. Then you can invent, that's what I was saying. You can invent the colors. I mean the categorical variables, you can invent them. So by inventing, we mean we have got here the days, and we have got the smoker. So if you see here, the X was the day, and then grouped by smoker. So we had the days, and then the smoker, and then in each day we are grouping into 2. You separate, it's a group or a separator into what, smokers and non-smokers, and smokers. But now you can do the opposite. You can put the smokers here, so that we have 2 parts, like part 1 for non-smokers and for smokers. And then for each of these main division, the smokers, you can group by, you can put hue by now day. It means now here you have these 4 days, they will be for non-smokers, they will be first 4 days, and then like that. Okay, let me just run. So when you invert, for explained, the smoker and the hue. Okay, the Y is the same because the one which you are plotting must be the numeric, which is total hue. But we're talking about these categorical variables, day and smoking. And the palette I've changed now to rocket. Okay, here you can see this palette. You can see this palette. This palette was the default one. The default one is the dark grid, which we did here. Here, up there. I think it was up here. Dark grid style theme. Okay, now if we want to change that, you can see the thematic of this is taking the one which I declared at the beginning, which is the default. Now here I changed so that you see I used white grid, and then white grid is looking like this. Here I used white grid, and then here I used pastel 1, so it's looking like this. Okay, after inverting here, I will use the rocket again palette. So rocket looks like, okay, I've not run, and we have swapped here. Let me run. So you can see rocket. Oh, we'll run the split. Okay, so it's fine because I already ran. I was supposed to run this one. Okay, so this is the rocket one. So you can see that this is the rocket. We have current scheme and the theme. Whereby this one, the palette, whereby here the current scheme is the here is pastel 1. Okay, so you can differ like that. See, but it's the same graph. But now we can invert it. This one we got inverted. We just wanted to see. Okay, we just wanted. Oh, so we have done two things. We have invented, but we've also changed the coloring scheme. Okay, so that's what I was saying, that these 4 will be in the no smoking, and these 4. So you can see that the days are here now. Over here, the days were at the bottom, the smokers were here. You understood what I mean. So it was correct here, but we have inverted. But now what about here? The split parameter which I've already run. The split, and I've used another palette which is magma. The split, so split true, you have to put it true. Otherwise by default the split is false. So that's why we didn't even put it. So if you put split true, then I already run here. Then what it does is it will do, because it was this one. Yeah, what it will do is instead of having 4, like here there were 8, like here. So 1, 2, 3, 4. But this one is the, which one is the smokers down? Yeah, so it's this one. So instead of having 1, 2, 3, 4, these 2 will be combined together. And then I mean this one and this one will be combined together. Okay, and this one and this one. Okay, let me just go here. So what will happen is they will split, so they will put together. So we have got like no and we have got yes. Now on no, you can see that on no last time we had all these. We had the first day, second, 3, 4. But now what I've done is this one. See, there are 4 colors here. Now this one will come together. This one and this one will come together. So I think you're following here. So what it means is you put them together. That's mean of splitting. Similarly do there. These ones there. Sometimes there's you want to compare them when you put them together. What we mean is because you want to see how the groups that are adjacent to each other, next to each other, how are they comparing. So you can use this. All right, and this is the magma. You can see how the grids are looking. Yeah, that's magma palette. The coloring, I mean, the way the coloring is looking like. Yeah, so I've changed it a little bit, different from the color that was there. Okay, the density chart. Okay, so the value now finished. The density chart to visualize the distribution of a numeric variable for one or several groups. So the density is for numeric. You can have density plot with a shade or without a shade. So with a shade you say fill true. If you just put false here, it will not have a shade. Let me first, or just remove the fill, or just put the false. So if you put false, or okay, let me put false. Then I make a density plot, and then here I just have to use KD. This is kernel density plot. So KD is kernel density, KDE, kernel density plot, and then I just put this was just a frame which you can set already. Maybe I'm using the white grid. If you don't put the theme here, number 2, it will choose. You can even remove this one, it will choose its own theme. Okay, I can comment for now so that you see. Then it's just number 3. That's why seaborn is very good, and you do with less code. It's different from matplotlib, and the others. Sometimes they need a lot of lines of code, but seaborn you just doing less lines. Okay, so because it's already structured, so that's why it's faster and it's seamless. Okay, now if I run this one, then it will be just a plot, you can see, but it is not filled with anything else, and it has used the one which we were doing before here, which was, what was it, magma. Okay, So now if I can use the white grid, run, then you can see that so the magma and white grid are not very different. But if you use another one, maybe if I used dark, then this would be different. Dark, so you can see this is dark, but this is not a filling, it's just dark, but you need to fill. So to fill, if you put false, if we put true now, true, then you have now the color red. Red is same as just putting R or red. If you run, then to fill in with red. See, if you put green, to fill with green, like that. You can put just some of them, they are not by one letters, but others you need, but if you put full letter, always it will be correct. So like that. Or if you want maybe khaki, just put in full khaki, but they should be small letters, not capital, no capital letter. So khaki, yeah. Let me put capital letter khaki. Sometimes some pages maybe they did. Yeah, it's okay. So some pages were not working, were case sensitive, but here you can use capital letter or small letter. I think these days people are simplifying. The softwares are simplified so that with the AI and like that, artificial intelligence, so it will know. But there are somewhere where you cannot use capital letter, like here on dark here it will not work, but for colors it's fine. But here it will not. Dark, no, here somewhere it won't be allowed. See, it gives an error. But on the colors, is fine. On the colors here, yeah. So khaki, if it was only one, you can just put K, but I don't think khaki is, yeah, see. But if a color which is the only one, then it works. Like M, maroon, it's the only one. No, if you put like that one now, not in full, then it should be a small letter. Maroon. So it's like that. What is this one? I don't know what the name of this color. But it's M. But if you put in full, like maroon, then to give the maroon color, which is the same as if it's a full name. If you put capital letters, there's no harm. Alright, I think you work with colors so that you understand. Let us move on. Now, that's when you fill a color. By the way, this one was for the grid. If I put the white. Again. So this is white, like that. Alright. Cumulative. You can see this density function is the density function by default is using the normal distribution. You can see the way it is shaping. Like this one is normally. So even if that was skewed like that, you will add some bumps or that. This one, the density function, is a smoothed one. We'll have to go smooth without bumps. And then it's an estimator. Estimator. Now we can accumulate. When we accumulate, we put fill true. That was for, but we put cumulative true. When you put cumulative true, you mean that you are allowing to accumulate. So it's the same graph which we had, but I've just changed it here. Put now the grid style with ticks. If you just do like ticks like that, then it does not have the grid lines here. So you just have ticks on the x-axis and the y-axis without grid lines inside, which is same as like white. But these ones, which was like this one, magma or whatever they would what. Magma was the color scheme, but this one was using the one which we declared before, the grid. This one, the white grid. It has got the lines, but just white has got no lines at the back, no lines like that. And then this one has got no lines, and then has got the ticks. That's the ticks one. But the true, we're interested in the true, so you can see that now it has accumulated, so it makes a curve accumulating like this. If you so this one will be an S shape always. That's cumulative. We want it to make it 1 to 1, so that as you go from left to right, you never go down. You either, we call it 1 to 1 correspondence. So, or bijection. So it's both injective and subjective. So we say by injection. And this is very important in statistics, this principle of cumulative density function, because it's a 1-to-1 function. What a density function, you see, was not a 1-to-1. It's going up and down. So this is the 1-to-1 one, which is an S shape, such that it can remain there or it can go up. It will never go down. It can remain constant or go up. But never go down. So that becomes 1-to-1. When you map with probability. In other words, it means as we go, the shaded area, which is the probability, is ever increasing from 0 up to 1. That's the good thing. And we use this one in most of the things, like in machine learning, computer science, computer engineering, and like the artificial intelligence, and many things. They're using this principle of 1-to-1 injection and subjection, which is the bijection. by injection, by injectivity. Okay, now why? Because if it's 1 to 1, the thing is that it will have it's a mapping which has got an inverse defined. Okay, so it's easy to map back, to do an inverse, an inverse function exists, and then it's easy to do some transformations and the like, and some simulations and some calculations in the statistics. Alright, now let's go to change the bandwidth. So the bandwidth, if you change it, by default you use 1, but if you change bandwidth method, if you use maybe 0.08, then let me run. So you can see, okay, the kernel based approach, but I will not put this one cumulative true, so it will be this one we have here, but by default it means it used 1. Okay, method 1, now instead of 1 we see 0.8, that's 1. So you see what happens. That's the effect of you can see the effect of the the method. I wanted to mention this one, bandwidth, BW is bandwidth, that's what I wanted to mention. So the bandwidth method, which means you see 0.8, okay, if I make it bigger, okay, the default one was 1. So the default one was 1. Let me run the default one. Yeah, you can see. So this one, when you use 1, that's the default one, that's what we had here. I don't think you are allowed to go beyond 1, because this is like a scaling. Let me try to see, go deliberately above 1. Where is it? Here, let's go above 1 and see. 1.2. Oh, it will allow. Alright, it's fine. So, but there will be somewhere where it may not allow. So, which means if you are making bigger like that, you are making it, it will be doing something else. Okay, for example, for that, so that you see what is happening. Let me do 5. See what's happening? It's like, I think it's becoming very big. Yeah, it's becoming big. Okay, but if you put a small one, like 0.002 or 1, like this, very small. You see the effect of putting it very small. So the bandwidth, if it's very small, it means it has got some impression. You lose some information when it's very small. So at least maybe 0.01 is better off, but it will be telling you like this. You see? Okay, so it depends on which you are doing. That's why I choose 0.02, which is at least looking like that. No, it was just 0.2, not 0.02, which is looking like, okay, I don't know what I had there, but you have seen what happens when you're changing the bandwidth. Okay, so I think it was 0.2, yeah. Was it 0.2 or 0.8? It was 0.8. Okay, because I wanted to leave it the way it was before. So it was 0.8, like this. Alright. Now let us go to density plot with several variables. So you can have several variables. Like here, you have got separate width. That's the two of them, which means you have this one, it will do a density plot, then this one, another density plot. If you have got maybe 10 of them, then you would just have the first one, the second one, we call it overlaying. You overlay on top of the other. So the first one will be we have color maroon, the other one is color blue. You see? Now the first one is the width, the second one is the length. Okay, you can see here. Okay, what I mean is this: if I can just copy this one, and then just enter here, and then this was sepal, but this one I can use the peto width, and the peto, the last one, the peto length. Okay, so the colors, I can use this one green, and I can use this one red. Okay, or I can put in full, red, green, whichever. So if I run like that, you overlay on top of the other. So there will be 4 here, like this. Hello? So there will be 4. So this is sepal width. But by default, this is one which I wanted to forgot. By default, the first one which was first named is the one which will remain the label for the x-axis. Because here, all of them are density by default. But this one here, it will be the same axis here. But here, it will name the one which was the first one. How can you overwrite this one? Which means you have to add the what? The label, the title. So the x, which is the title. Okay, we'll do next time. So you can do the x title. Okay. So histogram, to display the distribution of one or several numerical variables. So like here I'm using ticks again. Now it's a histogram, which means I need to display the data, and then I'm using histogram will have only one, so x-axis only, you will not have y-axis. Okay, unless if you turn on you flip it like this one, that's when you have the y-axis only. Okay, so in other words we have one dimension. Okay, so like sepal length here is on x-axis, or the same sepal length you can put it on y-axis. Color here is purple, color here is black. So what is happening is we are using the center set. It's the same one but flipped on its side, horizontal. Okay, let us do this one. So it will be this one, and the color here is black, so it will be black, and the ticks, which means it does not have a grid inside, and put the ticks here. Whereby this one, the flipped one, I've used dark grid, we'll have dark grid, and with the ticks means will go above the grid is a square, grid is the grid lines, and then this one, the color will be purple now, but y, we'll put y now instead of x, so it means instead of being a vertical bar, it will be a horizontal bar. So to flip on side, and the color has gone to purple. See, so it's purple. If the color I put here orange, what about if you put together with the density? So with the histogram and the density on top. You can also have a histogram and a frequency polygon, but here I just wanted the density. Okay, with the frequency polygon it's like a piecewise, but the density, we prefer density was the continuous, which is like a smoothed. While the frequency polygon is not smoothed. It's not really smooth. It's a smoothed of course, but you can see that with corners we join with lines. So while this one we say curve. So we prefer density to frequency polygon. Okay. Then if you what do we do? Say kernel density estimator. This kernel density estimator. True. But this one the color is dark blue. So this is the color dark blue, and then the sepal length, which is in x, which will be a vertical one. But what did I want? I wanted which one? But not on here. Alright, so we have the gray for the bars, but for here you can use white. They're just here, you cannot use any color. These are not colors, these are themes. Okay, you can check and see this, as I said, dark blue, like that, like dark, not blue but grid. Okay, that's the default one. Okay, so like that. Okay, so okay, then if we have this one, we can change back this one to dark blue, the way it was. Okay, alright, like that. Okay, so now you can see that we have got both the histogram and the, you can see this is not a bar chart. A bar chart has got disconnected, the bars are not connected, but here, only that here with the white lines there, but they are connected. It's not a gap, they are connected. Alright, so there's no gap. That's histogram, and then we will put a kernel density estimator, a smoothed function. Okay, whereby some people will join the midpoints. If you join the midpoint, you put a frequency polygon. You can do the bins and then do the midpoints and join there. Okay, you can write a code, do the frequency polygon, but also next time I can always show you how to put the frequency polygon. Okay, but now we're interested in the kernel density. Alright, what about controlling for the number of bins? Okay, you can see here the bins is choosing automatically by choosing the scale. Then it knows how many bins you should have. The bins is like the bars 1, 2, 3, 4, 5, 6, 7, 8, 9. It has chosen 9 bins. Okay, from 4.5 up to 8. What about if you specify yourself to say, okay, I want 40 bins? So it means you have to add the bins into 40. Kernel density estimator is true. Color is red. Okay, stop plot. Yeah, this is data set. I'm using data set 1. Okay, so here you see that for the 7 using data set 1, you see that here I uploaded data set 2, which I used here. Data set 2 I used only here. Let me go up here, only this one, on this one where we had the smokers and that one. So this was data set 2, but at the beginning here I had data set 1 for this one. This one was data set 1, see, which is different from these ones where with the smokers. This did not have the smokers. This was the data set 1 was the leaves, the flowers. Okay, with the petals, sepals, what. While 2 was this about the tips, the doors, the total bills, the size, the dinner and what. See, smoker and days. So when you had dinner and like that. Okay, now maybe it was a restaurant like that. So we used it here. So now here we're using again the data set 1. So we have 2 data sets we're using here. Soon we will load the data set 3. Okay, this was the bandwidth. This is if you've got many histograms, you can put them together on top of so many histograms, and all of them will field them. But if you didn't want them to have filled colors, you could just do without colors. If you didn't want colors, you could just do a false, which is same as 0. So false is 0, because this one in computer it returned to 0. 0 is false, like that. So if you run this one like that one, then you could have just like that without colors. Okay, I just forgot here. But if you want to fix the colors, yes, you use 1 or true. True evaluates to 1. So it's a 1, which is same as true. Then it will have the colors. Alright, or a yes or 1. 1 or true. Okay, now let's go back here. Let's see here, right here. So this beans automatically over 9. What about if we force it to have 40? Then it will make 40 beans. Okay, and I changed it to white color scheme. While here they are the same. While here was dark grid. Okay, so you can see that it's the same between 4.5 and 8, but now we will put many division of them. So this is much better sometimes, with more understanding of the distribution of the data set. Well, these are for distribution, these visualizations, okay, than having fewer of them. But it depends also, because if there are so many, again, sometimes it is difficult again to analyze and understand it properly. It depends. But like for this one, for sure, this one is giving more information. Okay? So you need to balance up. It's just we balance up these situations. Okay, social analysis. Okay, and then in box plot is another one now. This was the histogram. So far we've covered what we're doing. Because we have covered not this one, but we're doing the data visualization. That's in data science. We're using Python. So next time we'll do more about matplotlib, seaborn, plotlib, and the Part1. Okay, but what I wanted is that we have covered, so far we've covered the distribution, which is the viewing, density, histogram. Now histogram we've covered, so it's the box plot, and then we're remaining with the ridgeline and the B swamp plot. B swamp or swamp plot is one thing. So we're remaining with the box plot, which means we're remaining with the ridgeline and the B swamp. And the next time we'll go down to correlation ones, ranking ones, part of the whole ones, evolutions. That's same as progressions or trends. Evolutions is the trends or progression. And then we have got the next time we'll do again the mapping. We'll do the spatial mapping, geospatial. So we have the maps and then the flow for the traffic in the network diagrams, which we use also for in the neurosciences. We use the flow. So like network, neural networks, machine learning, we're using the flow graphics. Okay, so then we have this one, regional knowledge. Alright, let's proceed. Just the 10 minutes. So if we see now box plot, we should not waste a lot of time because I think we are more familiar already. So we should not waste a lot of time for box plot. Where is it? You summarize the distribution of numeric variable for several groups. Okay, so one or several groups. Okay, so which means I just said for several groups, that should be for one or several groups. Yeah. So like here, I've done matplotlib, pyplot is very important, and then also the numpy, that's for what numeric Python and manipulation, and then we have got the seaborn for and then the pandas also is for data frames manipulation. So the numpy and the numpy usually see the data structures, those ones, the vectors and the lists. The pandas is very good at the data frames, so they work together. Okay, so this one is for the algebra or some manipulation on the vectors, on the lists and on the data structures, while the pandas is more developed on the data frames, and then this one, the seaborn and the matplotlib, and also the the plotlib or the Part1 for the graphing libraries for graphs. The matplotlib is the inbuilt one, or should say the foundational one. So Python intrinsically or inbuilt is built by what? Matplotlib. These are the seaborn and they are built on top of this as extensions. Okay, for refinements. Okay, so we have the create simulate dataset here. So for here we are using simulated dataset. So which means G1, G2, these are groups. Group 1, Group 2, Group 3, Group 4, Group 5, and Group 5. The 5 groups. And then we use pandas concatenate. So the pandas have got a method concatenation. So this one you concatenate, and then that's the concatenates pandas objects along particular axis. Okay, so you can concatenate here all these ones here, you join together this data frame. So each of them is a data frame. Because this pandas data frame, this one you make a data frame. It's 2-dimensional, size mutable. So which means you are saying it should be group A, it should be labeled A, B, C, T, E, the name of the column. will be A, B, C, D, and then this is the name, is the name of the columns, while here is the number. So with the name of the column or the variable or the column in the data set, and then the number that you, for that group. I mean it's a group, so I should not say the column, I should say group, not column. So which means column, of course it works even if they were columns, it's the same thing. They're going to be columns or they're going to be groups, okay, but let us here understand them as groups, okay, not columns, but groups. So which means you go to group A, B, C, D, E, okay, and then you want 250, 500, 550, 150, 350, altogether is 1800. So 1800 will be the overall sample size. Okay. Now all of these ones you're using the normal distribution, except the last one I have used the uniform distribution, but you can use any other. Check my other videos, you have got so many techniques, so check my other video for data simulation. Okay, we have got the gamma, Weibull, log normal, Cauchy, Pareto, you've got the Wishart, you've got so many other, the beta, like that. Okay, normal, log normal, you've got the geometric, hypergeometric, you've got so many. Others are discrete, uniform, discrete, others are what, like hypergeometric, geometric, others are continuous, chi-square, student t, or these are like continuous. Okay, this are normal and like. Okay, now the Weibull gamma, I've already mentioned them already. Okay, so now this is the uniform, these are the normal, and you need to have the parameters. So these are the parameters. Okay, all of them will have the sample size at the end, and then you have the location. Here the location parameters, the first ones, and the scale parameters in the middle. Except the last one, we won't have a scale. We'll have the just the mean and size. For the uniform, we'll have just the size, which is the sample size. Then just the location only. Can say. Okay, now we'll have scaling. Okay, so, but these are the scales in the middle. Okay, now if I run through all of this one, then I can view the data set just to see the head and to see the tail. Okay, and then after that, then I use the usual box plot. So this is just a box plot, which is just this is data 3. I've put this one as data 3, which I've simulated. Okay, then when to upload the third data will be data from 4. Okay, so we have got X is a group because you remember here the column name was here. So when we said let's simulate a data set, so here that is with one column. The column is the one which is group. Okay, so the column is group, but named group. So in this column group, there will be the entries A, B, C, D, A, B, C, D, A, B, C, D, in such a way that there will be 250 A's in this column. There will be 500 B's. That's the meaning. There will be 150 D's in the same column. So it's one column of this data. You can see. So if you can see it, that's why here we are concatenating group 1, group 2, group 3. All these ones they are entering into to make a one. When you concatenate like that all together, then because of this group, when you say concatenate, it depends it all the nodes, so it will put in one column. Okay, that's why if you see here, it will just be one column. Okay, so to put in just a group, but it will have what value now is like, because you have said where is it? Here. Okay, display head and tail. So which means the value it will give the value of, because we had here where is it? Let me see. Yeah, the value. So it's like it will collapse into a table, I should say. So it will say A, B, C. It will start from A, B, C, D up to E. So each of them will be what? The value. The value, in other words, is like in it will be in line with how many for that one. What was the value that was entered for that one? The one that was simulated. Okay, so okay. Which is obtained from is the one which you are simulating, I should say. So it's like this is group A. I'm simulating a value 13.2 what from this sampling normal distribution. Okay, so it will sample 250 different numbers because we're simulating for A only. There will be 250. Then you go to B, there will be 500. Okay, I think you've understood. To make up 1,800 the whole column. That's why here down here. Okay, so it won't go to the end, but you see 1,800. And then, okay, if I just did this one only, you could see that it's 1,500. If I just said D3, F3 only, to tell you, yeah, it will tell you 1,800 times 2 columns. Okay, so let me run the whole of it. So again, so this is the box plot, and I used the VDS format, I mean palette. Okay, so this is the usual box plot, you see, and then this one when you use the set That's the one, the box 1 set here is the box 1, box plot number 1. You can put any variable name, but not reserved to it. And then you have used what, seaborn box plot. You have this one, and this is the grouping variable. You're grouping by what? By your grouping. It's a group by group, because here it was named as group. And then last time we here it was a group was a sex. Okay, somewhere here we had sex. All right, you remember. Then this one now. This one, the X label group, Y label value. You see, that's how you add. Use set to put what the label. So this is what exactly. So that is the box plot for several variables. That's the title. So you can have the for the seaborn. When you use seaborn, you can set. You can use set. You can set to change the titles. The main title. This is the main title. You can have subtitle as well, and then you can have Y label and you can have X label. Okay? So that's why here now, if I commented here, let me comment, then run, then you will have, but here to just put group and value as small letters, the way the variables were created here. Group and value, the way they were created here. Group. So here there were 2 columns. So create with 1 column group, and I should have said 2 columns. Okay, with 2 columns, group and value. So the 2 columns, group and value. So the group, you already put it ABCD as a character, while value is a numeric. Okay, a numeric way, which is coming from the simulations by these parameters, which is numeric here. While this is a group, so that you can plot this numeric value by this group. So which means you are plotting the values here for what? For group A, group B, group C. But these ones are entitled. But when now you set by this one, and it does not have the title, no title. Okay? But when you now remove this one, you just put this set, then it overwrites. It puts with now capital letter G, capital letter V, and then it puts here the box plot for several variables as a title here. You see, box plot with multiple groups, which we've already seen that now we can have. You can just create a display plot. You can just say data from 2, then you put the total bill, then you use smoker. So which means this one will have the subgroups, groups and subgroups. So we use this one. So the way we did it before, so this will group by smoker. So it means it will be this one, but by smoker. Okay. So that you have by day was x-axis, which means you must put x-axis. You must put the always the group, the factor, because the box plot is one frequency. So it's one way, it's not 2 way, it's 1 way. So it's 1 way, which will be the total bill only here. We have the numeric, but this going this way, it should be the days, like that. And then within the days, again, you put the smoker. That's by the grouping by the hue. So that's smoker, HUE. Okay, the hue means that that's the separation or the grouping. So that you have got non-smoker, smoker, non-smoker, smoker, like that. Okay. All right. So that's that. Then the last one, okay, but one with the bee swamp or swamp plot. So this one is not very difficult. You just put like swamp, like bees. Okay, so it reveals display individual data points without overlapping and resulting in swarming like a bees. Effect that resembles swarm of bees. It reveals the distribution of the data along a numeric variable, highlighting the density and variation of the data more effectively than traditional scatter plots or box plots. So this they give some more insights in addition to what we get from the scatter plots and box plots. Okay. Of course, they are not good if you've got a big data set, but they are good for small, reasonable data sets. So like a simple one here, if you just say my variable, you np and this one numpy random, use this method normal, then you have the location, the scale, and the size, which is n, and then this one, which means you here you simulate the variable, which will be 1000 data sets, and then figure. So you say the figure. You put here to say the figure size should be what you say x figure, then you put the option x should be what. So that is the should be 4 length, which is width, and then 7 height. That's figure height, and these are the what, the box plots. When you do like that, then when you use swamp plot, you just put y, you put the variable, because you swamp plot or box plot, whatever is the distribution of the continuous variable, which is my variable which you have simulated here, which you are putting it as y, and then as y axis always, and unless if you put on the x-axis it will flip. Okay, that's this one. If you want to changing the orientation, so you can change the orientation and okay, changing color and orientation that is the flipping, so you can flip. Okay, so you can just put port. Or let me put that. Okay, so now don't want that, but just like that. Okay, did I put the list inside? No, I didn't want this. Yeah. Okay, close. Okay, so what we're saying is if we run this one, then what we'll have is it's taking a little bit time because it's simulating the data set. After simulating the data set, we've got 1000, so it means these dots will be 1000, and then this looks like a base. That's why so you can see, and we put in such a way that they should not overlap, right? So that we try to make sure that each point is, we separate them a little bit. We don't put them on one point, so we separate them a little bit. If they, what it means is what we're doing is that when you take a line like a -5, okay, let's take a line like 5. If there are 16 of them, so the one which has got much wider, like here on 10 or here 12, it means like here 10, it may be 9 from here up to here. You can see, so it means there's too much distribution here. It's just similar to as well like the violin or like that. Okay, but here above there you can see it's narrower. In here it's narrower. So what we do is if you do by frequency, how many were 10s? If they were 100, we put 100 dots here. 15, if they were 50, you put 50 dots with something like a little bit equal spacing. So that's because here there is no scale here. Okay, so we just put them arbitrarily to say that maybe on 4, maybe only 2 here. There were how many? Maybe there were 10. Then we just put 10. So make sure that we put a center in the middle here, and just make sure that the plot in the middle one is the middle one, and then if we put the many, we put on the left, we divide by 2, and put on the other on the left, other on the right, other on the left, other on the right. If there are 6, we put 3 to the left, 3 to the right. That's what we do, or whichever. Yeah, let's just use that one. Okay, so then that is that. That's for the edges. Whereby I've got this is the color for the points, and then the edge color is black. You see? Okay, you can change these ones. All right. Then this one now, you have multiple, several of them. Like for example, if we simulate for 2 groups, group 1 and group 2. Okay, location and scale we are doing, we simulate with sample size, maybe where the sample size we use here to be 500, which means it will be 500, so there will be 1000. And you do the same we did like before, concatenate, so group 1 data, group 2, this is exactly what we were doing before. And then list this one, which means list that indicates the category for each data point. So we go to the group 1, you multiply by the sample size, plus group 2, multiply by the sample size again. Because these ones are 2, there will be 2 groups. Let me run. So it's like this. So there will be 2 groups here, because we have got 2 groups for this category feature. So we have got for this one, which is group 1, and for this one, which is group 2. Okay, and the label will be category, the one that you have labeled here. Okay, you can flip this one if you want. How do you flip it? To flip this one, you just swap here. Just swap here. So if you just swap, if you just put here Y and put here X. Just as the way as it is, just swap there. Okay, just swap there and run, then it will just turn vertical, horizontal like this. See now, to be the other one on top, the other one at the bottom like this. But the way it was there, the other one was on the left, the other one was on the right. So like this, the other one is on the left, the other one is on the right. Alright, like this. Okay, finally we've got the last one, the ridge line. So the ridge line that summarizes the distribution of a numeric variable for several groups. So each group is represented as density chart overlapping each other to use space more effectively. Okay, so important loading libraries, we import them as usual, and then you upload the data. So that's the third one I was saying. So if I just run the whole of this one, it will need me to upload the data here. So that's the third one, that's the last one, that's the graphics 3. Okay, so that's the graphics, Python graphics 3, this one. Okay, so this one, if you can see it has dates there, temperatures like that, and then Now you extract the months from here because there are months and years. So you can extract the months. So because of time, I'll just say this is how you extract the months. Okay. So use the pandas to date, time. Okay. So extract date, month. So which means we take the month there. This one we've not just the data frame 4 because we've kept it also. If we go here, we'll have now graphics. So with graphics 1, the data 1, we've already 1 and 2 and 3. Those others we're simulating, we've not saved yet, but if we saved, they would also appear here. But we just loaded them in the memory. Okay, we didn't save them. The ones that we simulated, because each time we're running the code, they will be generated and they will be used, and then they will not have memory. That's a good way. But these ones, because we don't want to be generating now again, we'll just be uploading and using them, named files. While those other ones were like the sketched files. Okay. So let us move on now. Now, if you do this one, see the head, you see already this, and then you define the dictionary. Okay, I can just run already. Okay, so we've defined the dictionary already, which will have this dictionary. Say 1 is January, 2 is that March, up to 12 is December. That's the dictionary that we're creating. It's a month dictionary. So this is a value key pair. So which means key value pair. So the one which appears first is a key. It's known as key value, not value key, but key value. So the one which appears first is a key. After colon, the one which appears next is a value. So which means 1, the value is January. 2, because it doesn't matter in the dictionary. Doesn't mean that a value should be a number. Doesn't mean that a key should be. But what appears first is a key. What appears after colon is a value. So we call it a key value pair. It's not value key pair, but key value pair. So these 1 and 12 are keys. January up to December are values of these keys. So when you access this dictionary by their keys, they will be giving the dictionaries, the months, which are the values in full. Okay, now, so you create a month column, which is this one. Okay, you can just see it so that you see. So you can see that this is the month column. It's now January, because the first one where 1 is January. After that, you will go to February. They will be put together. They are already sorted by month. Up to the last one will be December. Okay. You can see here you jump to those ones, and the mid one, those are the ones which will be December. Okay. The temperature will be positive, negative, because this is temperature. Minimum temperature especially, and the positive or negative. But the maximum, I think, and the mean, they will be all positive. And we can have also negative, the maximum or minimum, but rarely. But the minimum, that's where we can have negatives. Okay, in most cases. Okay, now we calculate the mean series. So the mean temperatures, because so we are making the time series data. Okay, because of time, I'll just run. So when we make this time series data, then we can give we can use a cool palette with the 12 colors. This one has got 12 colors. Just for the number of colors, then to divide the same. If you say 10 colors, 50 colors, to divide the same, because it has got so many colors here. When you say cool, so we are now like what call it the looping, traversing. Okay, so we are accessing. We call it the G axis flat. Okay, so the axis G axis flat. Okay, why? Because the G is the object, which is the data. Because we had here, we said G this grid, so we made a grid class, which is a G. That's why it's a grid. So when we make it grid, then we can have what grid? We use grid map to map the grid. This is the kind of density estimators for all of those ones, and then the lines, horizontal lines, okay, and so on. Okay, and then the axes as well. You can use the dictionary month, those months, which will be January up to February up to December. You increment them with an I of this, and then by the end of the day, you will have supports. So you can have the size here. If you want them to be overlapping too much, you put here maybe -10. If they overlap too much, you check my other videos. If you put positive, it means you are separating them far apart. Okay. So what are we doing here for the ridge? Let me just run. So you can see that's what the ridge is doing. So with the temperature here, and then you've got the from January up to December. So with January, February, March. Yeah. So if there are so many here, what we do is we make a curve like going to the right, like we are making a circle going to the right, and then coming back. It's like we make it like a circle because there are many. But if there were a few, we could just make it, they could do them just straight line. Okay? Yeah. So but we're not just doing it. Okay, that's another mistake. But in many cases, that's what they will happen. But we're not just doing it. We're following the temperatures. Okay, so it's like this is a pattern which we've seen from here. Okay, so it's not that always that's how it will be. But I mean, the pattern will be something like that, because you know that here in the middle here you can see the colors here. So here that's where it will be hot. See, the temperatures will be high. So here it will be hot. While here it will be cold. In December, whether the winter, spring, January will be cold, see, spring, winter. But when you go autumn and summer, see here, summer, August. So that's when we'll have the summer here. We'll have the high. So that's why in the middle it's going to the right. It's making like a circle because of seasons. So this is making sense. So of course, yes, always it will be like this. For any location, it will be like this. If you start with January, after that one, okay, no, but it depends on the where this one is, whether it's in the northern hemisphere, southern hemisphere, or equator, like that. But in general, there will be a trend like this. So it can be going like this to the right, or it can go to the left. It can make a square, like a circle going to the right, okay, or to the left. That's what I should say. Or yeah, it can be to the right or to the left, depending on that location. Okay, but what I meant was, if you change these parameters, like here, if you hold the horizontal space, that's a subgroup adjustment. If I put positive 5, positive 5, it means I'm separating them very far apart. Okay. Like this, see? It means I want to separate them very far apart, so you see what's happening. Very far apart. So they may not look nice, you lose some information. But at least it would be better, maybe, if you let me undo. It would be better if, where am I? Undo. Okay, here. It will undo again. If maybe I used, it was positive 0.5. Let me run now, but positive, which means it will separate. That one will be reasonable. Or even 1. Is it? Or even 1? Yeah, like this. So this is reasonable. So it depends. But if you wanted them maybe to overlap one another, we call this one ridge. We call this one ridge line plot, ridge line plot, because it's like there's a trend. It's like as we move from January up to March, there's something that's happening. Okay, let me do now. If I put a negative and I put 1.5, so that you see what is happening, or negative 1, so that you see what's happening. Horizontal space -1. It means I'm putting now one on top of the other, like this. You see what's happening. So this one really must be avoided. But if it was 0.98, yeah, that would be better. Let's see, or 0.7 or 0.8 would be better off. So you'll be checking which one, like this. So -8. So you see, but what it means is that you overlap them, because you don't want maybe to take too much space. You just want them to see on one page like that. So you can be balancing what to use. These are ridge map, so that you can see there are ridges, like when you're applying in the farm. So you can see also they're giving a projection or a trend, how like a time series as well. So the ridge line is also part of like the trend or the projections as well, or time series. Okay, lastly, we have the ridge line using plotly. So this is the last one. You can use plotly as well, because this one we have used matplotlib, I think. No, seaborn. I've used seaborn, but we're going to use plotly. These others we've been doing above, we're going to see we've been using seaborn and matplotlib. But this one, let us use plotly now. Okay, only that time. For in the other videos, I will also talk about plot9. Okay, the one which uses like the ggplot2, like the R. Okay. Okay, so these ones are the interface based, whereby you can use, you render them with the website, and then after rendering, then we're going to have the HTML hypertext markup language. Okay, you can use it with maybe CSS cascading style sheet, CSC cascading style sheet, CSS cascading style sheet, CSS. Okay, or HTML hypertext markup language. So you use those ones with the web browsing, and then you can embed using the frame, embed them in the into a web browser like that, website like that, and then you can do that as a a dashboard of these visualizations. So there are some dashboards you use like the Power BI, the Tableau, but the others you can just use web-based, the API-based. Alright, you render them and embed them on the website using just the links. Okay? The universal locators, URL. Now the source locators. Okay, now here we have this one, the ridge. That's what we're saying using plot. So what we do is we have loaded already some information above. So what we do is last time that other data. Okay, we have already another data set which was 3, but from that data set last time we were taking the months, January, February, but we can also take the years. But So if we take the year part, that's what we're doing here. So time I'll just run. So we've taken the year part. You can see now we see 1050 going down. Okay, up to 1015. Okay, if we saw the tail, this is the head. If we saw the tail, then this would be what we see the bottom one. Okay, so I can run again. So we see the bottom first, this one, and then the top. Sorry, not the top. This was the bottom. The head will be, because here the 1950 will be on the top because we're going down. So the head will be the older ones, and then the bottom will be the late ones. So it was from 1950 up to 2010. Okay. So we have the mean temperatures and that. So we've extracted the years. That's what we're doing here. And the year to date frame. What are we doing to store the year in a separate column, like that's how we're storing the month. And then we have these years. Okay. So we split these years, and then we got the line. Then now we plot. Using the plot graph objects as go. So go is for graph object. Okay. So when we do that, we use for loop. Okay. Because of time, I will not explain all this in full, but you can see what this is doing. You have the dictionary there, and then that was the array dictionary, which we must have the years list that we have here. We have divided the year list. See, so this will make an array, okay, like a list. Okay, so we make an array dictionary now based on that one, the year list year. So you say anything when you check in the list here, is it in which year? In 2020, in 2022, 2030, 2015. I mean 1980, 19 like that. Also for 1950. Then when it checks here, then it allocate accordingly to which group category you have there. Okay, so that you have, then you can sketch now the years versus. You can sketch the on the x-axis. You have the negative this one up to this one. Okay, but I wanted here. So we're using the dictionaries, and then the years, and then we'll have the values. So in short, we'll have the kernel density functions again, but for different years on top of the other. Alright, let me just run all time. And again, you can do the same to check so it's like this. And when you're going to be going there interactively, it will be so that's a good thing with Plotly. It will be, if you go there, it will be telling you like that when you go there. Also Plotline also does similar things, and these ones, both Plotly and Plotline, they are good at rendering on the web browsers. Okay, they're good for dashboards. Okay. Yeah, so all these features we're doing later on, we'll deal with dashboards at the end. Okay, so for today we'll stop here. Just once again, just 1 minute. I will say this topic. This video is a lot of graphics. We've got the distribution, which we've covered all of these ones: the firing, the density, the histogram, box plot, ridge line. That's what we've done as well, and the score plot. But next videos we'll do the correlation. So we'll do all these ones, the ranking, and then the part of the whole, the evolution. These ones we'll be doing. We may not do in one video, but we'll do again maybe two. I mean, like correlation and ranking. Then another video we may do again part of the whole, and this is the tree maps, the pentagrams, the donuts, the pie charts, the drones, etc. And then also the evolution, the line charts, and the like. That's for the progression time series. So I've done the number 1 today. The next will be do 2 and 3. Then another video will do 4 and 5. Then there will be another video we'll have to do again. These 3: the maps, the floors, and the general knowledge. Okay, so which means we're going with maybe 3 or 4 videos. So click subscribe so that you don't miss the next coming 3 or 4 videos. Alright, for today we'll stop here. Yeah. So this is the end of data visualization, data science using Python, using matplotlib, seaborn, Plotly, and Plot9 for today. Thank you. Bye.